Hello, good evening all. My name is Arjun Yadav Matapalli, and here we are discussing about two review articles on data analytics for supply chain management and medical medical applications by Anita P. and Nivedha Das. The topics covered under this are like how we are applying the data analytics for two main useful applications, supply chain management and medical applications, and how we are processing the data and how we are applying the data analytics to these applications and the techniques which we used in this paper. And applying data analytics for the supply chain management and the medical applications are very briefly discussed in later parts. And the sample data results, applying the regression, and we applied they applied regression model for the data and the future applications. And as per the recent studies, it is we are having large volumes of data on daily basis. It is 1200 exabytes data is generated, and out of this data, approximately 80% of the data is unstructured data, which we cannot analyze and process. It's very difficult. And in the form of the data is stored in the form of reports, queries, and the forecasts. The big data has evolved because of the unstructured data, which we are having, which deals mainly with the complicated data, which have huge volume and rapidly expanding, and which is generated by autonomous and independent data sources. Big data has a very wide range of applications like marketing, health, and optimizing to get an optimized solution for few problems. The big data term has evolved first in 1997 by two NASA researchers for visualizing large data sets. Data analytics and management, the big data extraction process has two components: data management and the data analytics. Data management deals with the process and supporting technology for gathering and storing large volumes of the data, and analytics deals with the anonymous data to have quantitative and qualitative results from the data to make the decisions. This is a simple block diagram, like a process diagram for big data process. It is having data data discovery and data preparation, and the evaluation and model execution and the visualization. Extract ELTL is extract, loading, and transforming and loading the data. Is performed on data while preparing the data. Before being imported into data warehouse, data must be converted and cleaned and audited. Large amounts of data have significant probability of mistakes. These are the main attributes for big data applications. We have volume, velocity, variety, veracity, value, variability, visualization, variability, viscosity, and these mainly deals with how used the data is and how the data is getting transferred from user to the data server, and how the data is structured, like whether it is structured or unstructured data, and how much the data is correct. And this is the while applying data analytics to supply chain management, this is a basic layout which has a supply chain management has these steps. And every step has will have some data generated at every moment while in operation. From planning to end customers, we have huge data, and the data is going in the later sections that we have collected some sample data, and we process the sample data by using some linear regression models to have the forecast. And Venkata Krishna will continue after this. Thank you.
Thank you all. I'm going to explain about data analytics and techniques used in supply chain management. In spite of large growth in the field of data analytics, which experienced by customer insights, analytics has many applications across end-to-end supply chain. And we have three types of analytics, which are descriptive analytics, predictive analytics, and prescriptive analytics. Going to the next slide. And we are going to discuss about the challenges of supply chain management. According to the Roebuck in 2014, The open research problem was designed along the logistics can be analyzed from the view of stakeholders and executive business components, where the key business functions are forecasting, inventory management, transport management, and human resources. Big data can address some issues like supply chain, like timely response, time delivery, real time planning, supplier and customer relationship management, and etc. These are the relationships between the companies. We are going to discuss about the big data challenges in logistics, which we have 8 types of logistics, which is distribution network optimization, green logistics, route optimization, space optimization, last mile delivery problem, redelivery consignments, and etc. And we are going to the next slide. Here where sustainable smart logistics. Logistic is a part of supply chain management, which procurement, storage and movement of goods along with the related information flow to manage the profit of the organization through cost-effective fulfillment of orders. And we have some logistics which are autonomous logistic, product intelligence, intelligent transport systems, and physical internet, intelligent cargo, self-organization logistics. Going to the next slide. We are going to discuss about regression. Regression is a collection of data mining or a statistical model technique used to describe the variables which the linear regression use the method of a straight line in order to predict the value of y by determining the appropriate values. And we have the two options, which are linear regression, coefficients of determination, and we have these are the two types. Going to the linear regression. Linear regression is a statistical method which is used to learn about relationship between responsible variables and predictable variables, and which is we have a formula which is y equal to mx plus c. And we are going to the coefficients of determination, which is coefficient of determination denoted by r, is output of regression analysis. This has been interpreted as follows. Here see the ranges from 0 to 1. R is 0 means the independent variable cannot be predicted from the independent variable, and if R is between 0 to 1 means that the extent to which the dependent variable is predictable. R is 0.1 indicates that 10% of variance in Y is a predictable from X. If it is 0.20, then 20% is predictable to so on. And I am going to hand over the Vinit Kumar.
Hello everyone, myself Vinit Kumar Reddy. Now I am going to discuss about the experiments and results of these two papers. This part includes a discussion of the experiments, their outcomes, a description of the data set, a synopsis of the scatter plot, representation, and information on PSPP. Data set description, PSPP, scatter plot, and interpretation of results. We are going to discuss deep into these topics. Next slide, please. Data set description. For regression analysis, a sample sealed data set of 25 was used. The file format of the data is set as a .csv, and table 1 tells about the list and describes the features of sales data. Next slide. PSPP, like PSPP is a tool for analyzing sample dataset statistically. This tool reads the data, analyzes it in accordance with the commands, and the outputs the result to the output window. PSPP is a free open source program for analyzing data samples, designed as a free alternative to IBM SPSS statistics in the late 1990s. Sorry. It features both a graphical and a command line interface. It is written in the C language, and mathematical procedures are provided by GNU Scientific Library. Next slide, please. Let's discuss about the scatter plot. It is proposed that the scatter plot be conducted on the sample supply data set in order to identify the linear connection between the variables, that is dependent and independent. The points on the graphs are linear. According to figure 1, this shows that the variables have a linear connection, and that basic regression may be used to solve the problem. Figure 1 shows the scatter plot. Next slide, please. Let's discuss about the integration of the results. Like table 2, 3, 4, and 5 shows the results of the regression model that was used on PSPP. Model summary, ANOVA, and coefficients are among the tabulations. Table 4 and a scatter plot in figure 5 shows the result of the basic linear regression. Predictions are almost identical to the actual value as seen in the table. It is somewhere around 80%. The coefficients of the determination are as calculated from the model summary. Falls between 0 and 1, or sometimes it may be 0.96. This shows that dependent variable is predictable. The dependent variable in this experiment is sales quantity February, which I have taken, which can be seen in a table 2. The variation in response per unit difference in a predictor is represented by the regression coefficients for the predictor. Table 4 shows the regression equation based on the coefficients. That is dv equal to 23411.25 plus 0.02 star IV. Next slide, please. These are the table 5 and figure 2. Next slide, please. Like there are some challenges which are used in there are some challenges in big data in healthcare system. Some of them are manageability, security, development, reusability, and maturity are the most significant difficulties. Thank you. Now I'm handing to Mahesh Chittimalla.
Mahesh, you are muted. Can you please turn on your mic?
Yeah, sorry for that. Hello everyone, this is Mahesh, and I'm going to speak on big data analytics for medical application paper. So big data analytics in use. So big data is one of the most advanced technology that is applicable in the management. The best upcoming use of big data is medical. There are many past and future techniques that are used in this paper. They are mentioned below. First, let me tell which are related to heart. First one is like a heart attack prediction, analytics of coronary artery heart disease, and early stage heart attack detection, heart disease prediction, and intelligent heart disease prediction system, and some other like brain disease prediction of disease outcome, using HIVINE or analyzing diabetes, tuberculosis prediction, and diagnosis of chronic kidney disease, and the final one is HIV/AIDS disease prediction. Coming to the next slide, there are some technical specifications. So here R programming language, software frameworks for statistical analytics, It is a collection of operators that are used to apply on the arrays and metrics. It is well developed with limited use of loops, user-defined recursive functions, inputs and output devices. And here is a picture which shows how will big data transform the healthcare system. So there are some like telemedicine, remote patient monitoring, mobile workflow, and care coordinator solutions, information enabled smart devices, and big data population health management. Coming to the next slide, there is a research analysis. Like statistic includes the concept of collection, settlement, scrutiny, representation, manipulation, clarification, and presentation of significant information. It uses two types of statistical analytics, like inferential analysis and descriptive analysis. Coming to inferential analysis, after the descriptive of information, every individual will need to divide with the legal numerical analysis approach inappropriate for further examination of the data, and they are of broad results which will be helped by judgment of visualization ways to manage many different types of data and establish relationship between them. A variety of numerical algorithms have been proposed, like Wikipedia, training goal, and eHow sources. Coming to descriptive analysis, here is the statistical phenomenon is a total derived or obtained from the information, such as an intention or a standard error, and it can be extremely useful just before exploring data to obtain an accurate set of applicable pictorial statistics. And the final slide is future works. Coming to the next slide. Okay. Future big data analytics trends in healthcare have the capacity to boost and speed up interaction among clinics, administration, lab directors, logistic managers, and researchers by lowering cost, increasing efficiency based on the result comparison, lowering risk, and improving personalized care. And the following are some of the anticipated future trends in medical big data analysis, like text analytics application used for e-hospital, e-antibiotics, and identical case recovery functions, genetic applications, excavative and study of biosensor functions, and applications related to social media investigations, and business and organizational designation applications. And the rest of the part will be continued by Venkatesh.
Yeah, hi everyone. So are you able to hear me, right? So everyone. So in this presentation, so we are going to talk about the how the data analytics which are going to applied in the supply chain management and medical science. So the form of generally the data is stored in the database, and like tables, it should be saved in a file, CSV file or XML file. It may be in the image. So generally what we are going to do, the raw data can be transformed into the useful information by doing the descriptive analysis and predictive analysis, diagnostic analysis, and prescriptive analysis. So in the healthcare domain, it is also used in reducing cost and reducing the risk of new diseases on the patient and improving the care based on the result comparison. So large business systems generates the data in terms of the files and the databases, images, PDFs, and generally the data is stored in the large systems like databases like Oracle database, MySQL, and these are all the large database systems which are going to handle the supply chain management data and the medical information. So please move on to next slide. So to organize and clean the data, so generally the raw data will contain unnecessary fields are accumulated in the table form. For example, if you take the table or if you take the CSV file, all the fields should be there. So we need to organize that one and we need to model the data. So here we are going to use data modeling. So for the organizing the data and clean up the necessary fields which are required to generate the reports based on the user requirements. Suppose one of the best tool in the big data. So we are going to talk about the Informatica. So this is the tool which is going to load the data, extract the data from the sources, and do the transformation and load data into the target tables. It means the target data warehouse, that's a OLAP. So what is a source? It's like a OLAP, online analytical processing. That's a source which will generate the data by whenever the user is giving any inputs into the system. So suppose if you are doing any application, if you want to book any order, anything, something like that, the backend, the application will generate the record into the source. So doing the analysis on data, generating the reports based on the required information, so mainly we used to get the information. We need to know how my business is there, how my administration is there, how many employees are there, so like this. It's on. I mean, in terms of the medical field as well, we need to know how many patients are there, what is the patient's information, what are the we need to diagnose the patient's diseases. So for this, data analysis is the best one to predict everything and to gain and to know the more information about the in terms of the product or in terms of the person. So there are a lot of tools available in the current market, such as Power BI, Tableau. So these tools are used represent the data in the visualization. So after doing the extraction after doing data loaded into the OLAP sources, and from there we are going to use we use the Python programming, or we use the Tableau or Power BI directly connected to the database systems, or we can use any CSV files, and then from there we'll generate the analysis. It's like analysis like monthly revenue, how the year budget, how the employee turnover, how the patient's information, like that. So Python is also one of the effective way to extract the required information from CSV file or a table in a database. And here we can plot the graphs directly, and we can do some examination how the data is going to represent there, and how the user requested information, whether it's in monthly or yearly, or it's like something like product wise, something like patients wise, and it's like diseases wise, how many diseases. So this is the most important thing when we observe last pandemic. So due to the COVID pandemic, so when we see there is a lot of less in terms of data visualization in the medical field. So because of that one, the patients, whenever they are affected with COVID, they don't know where's the availability of their slots in the hospital, how many slots are available for the COVID. So they don't know information, they don't know proper information across the world. So this is the way, by doing the data analysis, this is the way we can easily give the good administration to the public, to everyone all over the world. So in terms of the business, we can give good administration. In terms of the medical field, as per administration, we can give, and as per a public also, we can provide the best. Data in terms of they can easily understand by doing some. They're seeing data in terms of the graphs, charts, and everything. So. So that's all from my side. As we all everything is done. Good job to completed all the analysis part in terms of the supply chain management and the data analytics in medical field. So